Kia ora. Gradients of curves. The graph of a gradient function shows the slope of the original curve at every point. So here's an example. So we looked at this last year, that idea that if you have a positive cubic, when you differentiate it and get its gradient function, it would look like a happy face parabola. So have a think back to last year about how we covered that. And that's basically what we're going through in this topic today. So some of the points of interest that we'd see here is that we had the positive gradient going up in that cubic, and then there was a turning point, and then it went down in the negative gradient, and then it went back up in the positive. So then it's looking at those gradients, looking how it's changing, and then working out how to graph it. So let's go through the steps. Sketch a gradient function. Firstly, note where the gradient is 0. In other words, those maximum and minimum points or turning points. Decide between these points whether the gradient is positive or up, so putting little plus signs, or negative, down, putting those little minus signs. And then you sketch the curve. So looking at this example, here's a point where there's a 0 gradient, and here's another point where there's a 0 gradient. So the gradient function cuts the x-axis at these points. Decide the nature of the gradient. If it's going up, it's positive, and if it's going down, it's negative. And last year I talked about the idea of a little skier, a little person on skis. So let's have a look. So that person's climbing up, or a climber climbing up, or skiing up somehow, going down in the negative there, skiing down, and then climbing up in the positive. So the gradient function will be above the x-axis when the gradient is positive. So this is in our derived function that we're graphing. So the steepest gradient, try to decide where the gradient is steepest. At these point or points, the gradient curve will be at its maximum or its minimum. And this is usually about halfway between the intercepts already marked. So coming back to here, where is that steepest point? And we'd have a look here and see that that would be the point as labelled. So the gradient function will have a minimum at this point here. Sketch the gradient curve. So you now know where the gradient curve cuts the x-axis, where its maximum and minimum points are. So what are you waiting for? Bear in mind from last year we talked about this is just a sketch, and that the actual gradient value that you would be reading off a graph would just be an estimate of some sort, and we spoke about that last year in detail. So the 4 key steps: the x-intercepts in line with the maximum or minimum points on the original curve. Above the x-axis is when the gradient is positive, below the x-axis when the gradient is negative, and the highest and lowest points in line with the steepest parts of the original curve. And then you just sketch the curve. So the gradient of the graph of a function f of x. When the gradient of f of x is equal to 0, the gradient function f of x will cut or touch the x-axis. So have a look at that. What we had there is we had a negative cubic, and when we differentiated it or graphed its gradient function, it was a sad face parabola. So these points on the x-axis should be marked first because they're the turning points. When the function is a straight line, so for the second part of that graph, the gradient function f of x will be horizontal, because when you differentiate a straight line, like we learnt last year, you get yourself a horizontal line with 0 gradient. With a set gradient. When the function approaches a horizontal asymptote, the gradient function f of x will approach the x-axis as an asymptote. So that's given with this question here, that having a look at what's happening with that blue line, with its gradient, and then see how that correlates to what the gradient function would look like. When the function approaches a vertical asymptote, the gradient function f' of x will also approach a vertical asymptote. So again, having a look at what's happening with the gradient of the blue lines and then seeing what the gradient function would look like. So what about this one? So hopefully what you see there is you've got a negative cubic. So we should get a sad face parabola. This one here, an unknown graph, but if you identify the turning point that we can see there and the gradients, we should end up getting a sketch that looks like this. So there you have it. Now go to your exercise book and work on page 255, exercise 14.06 from your Delta textbook. Good luck.